Hi everybody, and once again welcome to my channel Echelon Tutorials. I'm Pankaj sir, and today I'm going to continue with a simple numerical based on this limiting reactant that we discussed in the previous video. So today's video is for this numerical. Okay, so you can see in front of you, this is the numerical which says that how much maximum amount of magnesium oxide in moles, they want the answer in moles, can be made with 7.8 moles of magnesium and 4.7 moles of oxygen. Moreover, he's asking you which is the limiting reactant. Okay, and the answer is written over here by me. Okay, it is magnesium, so let it be for you as well. And which is the excess reactant? I've written the answer for you. It is oxygen. And how many moles are left? Okay, then the answer for that is 0.8 moles of oxygen. Let the answers be for with you for reference. Okay, purposely I'm keeping you the answers with you in the beginning itself. Okay, so the concept has been already discussed with you about this limiting reactant in the previous video. And if one has not seen that video, please go to that video. It will help you a lot. So now this question says that how much is the maximum amount of magnesium oxide that can be obtained when 7.8 moles of magnesium and 4.7 moles of oxygen are made to react with each other. Okay, so basically we should have a reaction, chemical reaction like 2 mg plus O2 giving you 2 MgO. Now this is a balanced equation. Okay, it is already balanced, right? Because even otherwise you will have to balance it, right? So this is a balanced equation right now in front of you. So now the question says that 7.8 moles of magnesium and 4.7 moles of oxygen are made to react with each other, and you have to say how much magnesium oxide is going to be formed, right? So now maximum amount of magnesium oxide is produced with the uh, this one. Okay, the limiting reactant. Okay, so the amount of magnesium oxide that will be produced will totally depend upon the amount of the limiting reactant, not the amount of the excess reactant. Okay, it will be depending on the amount of the limiting reactant, and that is why you have to decide which is limiting reactant and which is your excess reactant. Okay, so to find out which one is a limiting reactant, okay, you'll have to do this, which I've taught you in the previous video. You have to use this formula for K, and K is nothing but limited reactant constant, you can say. Okay, LRC, limited reactant constant K. And it is given by the formula given moles of that particular reactant divided by the stoichiometric coefficient of that particular reactant. So let us try to find out first the limiting reactant constant for magnesium Mg. Now, how much moles of magnesium is given to us in the question says that 7.8 moles of magnesium is given to us, right? 7.8 moles of magnesium. That divided by the stoichiometric coefficient of magnesium. Now, if you see the reaction, the balanced reaction, okay, the balanced chemical reaction, you will see that in front of magnesium there is a 2. So this 2 is nothing but the stoichiometric coefficient of magnesium. So 7.8 divided by 2 will give you 3.9. Okay, store this in your memory. Now do the same thing for the other reactant, which is oxygen. So for oxygen, the given moles is 4.7. So that divided by the stoichiometric coefficient of oxygen, because there's nothing in front of oxygen, that means there's a 1. Okay. So stoichiometric coefficient for oxygen is 1. So it will be 4.7 upon 1, which is 4.7. So both the constants you have with you. Now the rule says that whichever value is smaller, okay, that will be the limiting reactant. And it is very clear that 3.9 is smaller than 4.7. So the limiting reactant has to be the corresponding reactant, that is magnesium. So you come to the conclusion that yes, magnesium is the limiting reactant. Okay. Now this was the shortcut method. Okay. Now I want to explain you the actual meaning of it. Okay. Now what is happening, to find out which is a limited reactant. Okay, see, either there will be magnesium as a limited reactant or oxygen. So what you have to do is you have to ask this particular question to yourself. Question number one: to use all of magnesium that is given to you, how much magnesium is given to us? 7.8 moles. Okay, so to use all of magnesium, how many moles of oxygen is needed? Okay, and try to find out the answer to that. If you find the answer to that, you will get the answer as 3.9 moles of oxygen is needed. Now ask the question for oxygen. To use all of oxygen, okay, how many moles of magnesium is needed? Now how much oxygen is provided to you? 4.7. So to use all of 4.7 oxygen, how many moles of magnesium is needed? And you will find that the answer will be 9.4 moles of magnesium is needed. But this is something which is creating problem. You don't have 9.4 moles of magnesium for the oxygen to react. Okay, you have only how much? 7.8. Right. So what happens is here you will get a clue. So one of the reactant is in excess and the other one is in limiting quantity. Okay. So the rule says that whatever is, giving you the answer as a smaller value, okay, corresponding reactant will be the, this thing, limiting reactant. Okay. So here 3.9 moles of oxygen is needed to completely use the magnesium. Okay, so your magnesium is the limiting reactant. Why? Because magnesium is going to be run out first. The magnesium will run out first, it will get used up first. Oxygen is not going to run out first. Okay, it is the magnesium which is going to run out. And the definition of limiting reactant is that only the reactant which will run out first, okay, in a chemical reaction, that is known as a limiting reactant. So magnesium is going to run out first, and so magnesium is the limiting reactant. So it has been decided now that magnesium is the limiting reaction. Now this is the concept, this is the logic behind deciding why magnesium is a limiting reactant, and this was a very shortcut method of deciding which one be the limiting reactant. Okay, both are one and the same. You can always use shortcut method when you are doing your numericals. Okay, so now you came to know that magnesium is the limiting reactant. So magnesium will be responsible for deciding how much magnesium oxide will be obtained, because magnesium oxide will be obtained from this magnesium only. Okay, because magnesium is something which is going to run out first. So to work out maximum magnesium oxide that will be obtained from maximum magnesium, what you have to do is you have to use this particular method. And this method also I have discussed in our earlier video. Like you have to start with what is given and you have to end with what you want. What you want now is how much moles of magnesium oxide will be obtained, because the question, if you go back, you will see that what is the maximum amount of magnesium oxide in moles, right? So they want the answer for magnesium oxide that will be produced in moles. Okay, so to get that answer you have to start with what is given. So given is 7.8 moles of magnesium. Can you see this? So start with this 7.8 moles of magnesium. And now you want mole to mole conversion. This is 7.8 moles of magnesium will give you how much mole of magnesium oxide. So this is mole to mole question. Okay. From X mole, you should get X mole of other substance. Okay. So this is mole to mole conversion. So in mole to mole conversion, you will have only one factor. You will have only one factor. And that second factor ka ratio, you will have to decide how. You will have to go to the reaction. Now, what is the reaction? The reaction is uh, 2 mg plus O2 will give you 2 MgO, isn't it? This is the reaction, right? So we are now concerned with magnesium and magnesium oxide. So from magnesium to magnesium oxide, put an arrow this way. It is 2:2, right? So you have to take in this bracket. Now I'll write this for you again. 7.8 mole of oxygen. You have to start magnesium, sorry. You have to start with this because this is something which is given, right? And yeah, this is something which is given. Okay. And you have to write a conversion factor, that is something upon something. Now this ratio will be, now see, you should write this ratio will be 2:2. Okay, but what will be in the numerator and what will be in the denominator, that is also very important. So in the denominator you should have mole of magnesium. Mole of magnesium. So mole of magnesium is this 2. You will write 2 mole of magnesium because this mole of magnesium here and this mole of magnesium here has to be cancelled out. Okay. Now what is left for the numerator? In the denominator you will write 2 moles of magnesium. In the numerator you are going to write 2 moles of magnesium oxide. So write 2 moles of MgO. Now nicely you cancel out this 2 and 2, you are left with 7.8, and here what is written, mole of magnesium oxide. Now this is your answer. So from starting with 7.8 moles of magnesium, how much magnesium oxide will be produced? It will be 7.8 moles of magnesium oxide will be produced. So you got the answer to how much quantity of magnesium oxide will be produced. And see, this magnesium oxide was dependent totally on the amount of magnesium present, okay, not on the amount of the other reactant, that is oxygen. Fine. Okay, but let us try to find out the answer to this third question also. What was the third question? How many moles are left? Okay. Now tell me, in this reaction, what is happening? Magnesium is reacting with oxygen to give you magnesium oxide. And magnesium being a limiting reactant, it will get used up. By the time reaction is over, the magnesium is going to be used up. So it will be, the magnesium left out at the end of the reaction will be 0 because it is getting used up. But what about oxygen? Oxygen is something which will be left out because it is the excess reactant. Okay. So the answer to the question like what amount of this reactant will be left out. So first you have to decide which reactant will be left out. It will be the excess reactant. Excess reactant is oxygen. So excess reactant oxygen, how much it will be left out, that if you want to find out, then do one thing. Find out how much oxygen is used up, okay, to react with the total 7.8 moles of magnesium that was provided to us. And we just found out the answer for that to be 3.9, isn't it? Somewhere over here. Yeah. While finding the this thing limiting reactant, we found out here that to completely use all the magnesium, all means 7.8 moles of magnesium, how much oxygen was needed? 3.9 moles of oxygen was needed. Now here is the clue. You have been given 4.7 moles of oxygen and your oxygen being used is just 3.9 moles. So there will be an excess of oxygen to the amount 4.7, take away 3.9. So 4.7 minus a 3.9 gives you 0.8. So this 0.8 is nothing but the moles of oxygen which will be left over at the end of the reaction. So in this entire reaction, what all things are happening in terms of moles to the reactants and to the product and to the leftover reactant has been discussed totally, right? And now there are more numericals on this limiting reactant that I want to discuss with you all, but this will be perhaps in the next video because now I don't have much time. So this video I'm going to end here and here itself. So in this video we discuss a single problem, numerical, relating to the magnesium and oxygen mixing with each other to give you magnesium oxide. But here in this question also, in this numerical also, I have explained you what is limiting reactant, how to decide which is limiting reactant, and what is excess reactant, and how to find out what is the left out quantity of the excess reactant. So that was this particular video about, and that's all for today. If you happen to love my like my video, okay, please subscribe to my channel, and thank you very much for being with me.